Dear student, welcome to all. In this presentation, we have to discuss about semiconductor electronic devices in modern society. These are the content of this presentation. Introduction, types of semiconductor devices, diode, forward bias and reverse bias, transistor, types of transistors. Introduction, semiconductors. The material science, based on the electrical conductivity, materials can be divided into three types. They are conductors, insulators and semiconductors. Generally, all metals are act as a good conductor because of metals have plenty of free electrons in which these electrons can move easily from one atom to another. So it is called conductor. At room temperature, the resistivity of a good conductors will be of the order of 1.7 in 10 power minus 18 ohm meter. In insulator, which have few free electrons, moreover, in which electrons are tightly bound to the nucleus, for example glass, mica, plastics, rubbers, air, etc. The resistivity of the insulator is 7.5 in 10 power 11 ohm meter. These materials those materials whose resistivity lies between that of good conductor and insulators are called semiconductor. For example, germanium, silicon, arsenic. The resistivity of the semiconductor is 10 into 10 power minus 2 to 10 into 10 power minus 3 ohm meter. Generally, semiconductor can be classified into two types. They are intrinsic or pure semiconductor, extrinsic or impure semiconductors. The pure semiconductors have poor conductivity at room temperature. However, the conductivity of a semiconductor is slowly determined by the thermally generated carriers. The extrinsic or impure semiconductors are synthesized by minute amount of impurity is added to the pure semiconductor. There are two types of extrinsic semiconductors. They are N-type semiconductors and B-type semiconductors. When trivalent atoms added to the pure semiconductor, we can get B-type semiconductor which have excessive positive holes, whereas pentavalent atoms added to the pure semiconductors, we can get N-type semiconductors. Here the negative electrons are available in excessive, so the conductivity of the semiconductor is increased at room temperature. So the pure semiconductors cannot be used in electronic device fabrications. The BN junction is formed between the B-type and N-type semiconductor. In this session, let us know more about the BN junction. The BN junction is an interface or a boundary between two semiconductor material types, namely B-type and the N-type inside a semiconductor. In a semiconductor, BN junction is created by the method of doping. The B side or a positive side of the semiconductor has an excess of holes. The N side or the negative side has an excess of electrons. The process of doping is explained in further detail in the next section. This slide shows the BN forward bias of the BN junction diode. When the B-type is connected to the battery, the positive terminal, and the N-type to the negative terminal, then the BN junction is said to be a forward bias. When the BN junction is forward biased, the built-in electric field at the BN junction and the applied electric field are in the opposite direction. When both the electric field add up, the resultant electric field has a magnitude lesser than the built-in electric field. This result in a less resistive and thinner depletion region. The depletion region resistance becomes negligible when the applied voltage is large. In silicon, at the voltage of 0.6 volt, resistance of depletion region becomes completely negligible. The current flow across it unimpeded. This slide shows the reverse bias of the BN junction diode. When the B-type semiconductor is connected to the battery's negative terminal and the N-type is connected to the positive side, the BN junction is reverse bias. In this case, the built-in electric field and the applied electric field are in the same direction. When the two fields are added, the resultant electric field is in the same direction as the built-in electric field, creating a more resistive, thicker depletion region. The depletion region becomes more resistive and thicker if the applied voltage becomes larger. When reverse bias is given to a diode, a very small current flow through it. This current is due to the movement of the minority carriers of charge. When the reverse bias voltage is increased, the kinetic energy of the electron also increases. When these electrons collide with a crystal atom, they may knock out electron from the covalent bonds of the semiconductor material. In this process, the covalent bond is broken and a pair of electron and a hole is generated. Thus, one electron on collisions with crystal atom generate a pair of an electron and hole. In this process, the number of free electrons and holes goes on increasing. This cumulative effect is known as avalanche multiplication. Due to this large reverse current flow through this junction, now the diode is said to be in the avalanche breakdown region. The current is not controlled by external resistance. The diode may be permanently damaged. The transistors have revolutionized the electronic industry since they were first invented. It was invented by John Paradine, Walter Hauser Broughton, and William Shockley in 1947. Transistor is an electronic component that is used in circuits to either amplify or switch electrical signals or power, allowing it to be used in wide array of electronic devices. A transistor consists of two PN diodes connected back to back. It has three terminals, namely emitter, base and collector. The basic idea behind the transistor is that it lets you control the flow of current through a one channel by varying the intensity of a much smaller current that's flowing through a second channel. There are many types of transistor and each transistor specializes in its application. But the main classification of transistor is as follows: transistor, BJT and FET, PNP transistor, NPN transistor, JFET, JFET and MOSFET. This slide shows the PNP transistor. When a thin layer of N-type semiconductor is sandwiched between B-type semiconductor, the resultant is the formation of PNP transistor. Similarly, when a B-type area is sandwiched between two N-type semiconductor, we have a NPN transistor. PNP and NPN transistor and their circuit symbols are as shown in figure. The transistor action can be understood by analyzing the current flow. through it under the influence of externally applied voltage. The emitter base junction will be forward bias and the collector base junction will be reverse bias. We will study the action of PNP transistor and the circuit is shown in figure. As the emitter is forward bias, the holes in B region are injected to the base and the electrons are injected to the base, and the electrons are injected from N region to B region, but the base is slightly doped and the emitter is heavily doped. The number of electrons from base to emitter is very small compared to the number of holes. The base region, some of the holes are neutralized by the electron. Since the base region is very thin, most of the holes will cross this region, will reach the collector region. Since the collector base region is reverse biased, the holes arriving at this junction attracted and this constitute a collector current. The emitter current is denoted by IE, the collector current is denoted by IC, and the base current is denoted by IB. It will be found that IC equal to alpha IE, where alpha is the called current gain, whose value will be between 0.95 to 0.98. The emitter current is equal to the sum of the collector current and the base current. This slide shows the NPN transistor. When the emitter base junction is forward biased, a small voltage VP voltage barrier voltage is seen. Reverse bias voltage, the due to the forward bias, the majority charge carrier in the emitter are repelled towards the base. The electron hole recombination is very small in the base region. Since the base is lightly doped, most of the electrons cross into the collector region. When the emitter is forward biased, the electrons moves towards the base and create the emitter current IE. Here the majority charge carriers in the B-type material combine with the holes. Since the base of the NPN transistor is slightly doped, it lets only a few electrons to combine and remain current is known as the base current IB. When the collector region is reverse bias, it applies a greater force on the electrons reaching the collector junction and hence attract the electrons of the collector. This let's show the advantages of the semiconductor electronic devices. The transistors have many advantages over the vacuum tubes. They are smaller in size, use less power, have a longer lifespan, and are more rugged. They can be used in integrated circuits where many transistors are fabricated on a single chip. The BN junction diode also used in LED bulbs and photodiode materials. The transistor can be used as a switches. That advantages which transistor switches offer over mechanical switches are that there are no moving or wearing parts. They are easily activate from various electrical inputs, and associated problems such as contact bounce and arcing are essentially eliminated. Thank you.